Hello, cherished viewers out there. I welcome you once again to yet another lesson on my YouTube channel, Rediscover Your Touch. And we'll actually be continuing with our second theorem concerning plane geometry 2. So we'll be discussing the tenets of circuit theorem 2, and just as it has been depicted on the board, we'll actually be taking a subsequent illustrative example as well, and we'll be able to fathom with how well we can manipulate this theorem in order to adjust to the questions that we'll be facing. So prior to our commencement, I'll urge each and every one of you there to take 1 minute out of your time to subscribe to my YouTube channel, to like this video, and to share among your colleagues as well who might be in need of this knowledge. Alright, so without wasting my time, we'll commence with getting ourselves abreast with the circuit theorem 2. So I'll quote the statement, I'll explain the statement as well, and then we'll apply that same statement or theorem in order to get over our illustrative example. So I trust we can start. Alright, so we have theorem 2. Angles subtended by the same arc or chord anywhere at the circumference in the same segment are equal. And I quote once more that angles subtended by the same arc or chord anywhere at the circumference in the same segment are equal. So we'll actually be looking at what really is the meaning concerning this theorem. What this term implies is that if we have chord AC, or we are talking about arc ABC, we are interested at the angles at the circumference that are having their foundations on either chord AC or arc ABC. I trust you get that. So we are interested in the same arc ABC or the chord AC, and we will actually be targeting our attention onto the circumferences or the angles at the parts of the circumferences. So we'll actually be having how our values are really going to be illustrated as well. So supposing we have our angle AFC, our first angle AFC to be, let's say, X. Okay, as far as this theorem 2 is concerned, and as long as we are having a usual or the same chord, that means that angle AFC must be equal to angle AEC and subsequently angle ADC. So in order to maintain the same structure, we'll also label angle AEC as similar to the same variable x, and that also implies that our final angle at ADE is also going to give us angle x degrees. So you see, just by paying attention to the rules, it implies that whichever angles are being represented at the circumference on the same chord or on the same arc ABC must be really equal. And for that matter, I trust this aspect of circuit theorem is easiest, because as far as we are having equal angles, we actually don't have difficulties with that. So we'll actually transcend this theorem into the illustrative example as illustrated on the board. So we are having angle ADB, to be 45 degrees, and we are tasked with finding angle Z. So angle Z is the same as ACB. ACB. But here our chord is chord AB. Line AB becomes our chord when we actually compare it to the illustrative aspect of the theorem. So we have line AB to be our chord, and we have angle ADB being 45 degrees, and angle ACB, which is the same as angle Z, are both lying on the same chord AB. Are both lying on the same chord AB. So our solution is going to be that angle ADB is equal to angle ACB. Angle ADB is equal to angle ACB. And for that matter, we are really going to have our chord to be similar. And we know that angle ACB is equal to Z degrees. Angle ACB is equal to Z degrees. So our Z, therefore, is going to be 45 degrees. Our Z is also going to be 45 degrees. Why? Because angles suspended by the same arc or chord anywhere the circumference in the same segment are equal. So as far as both angles are relying on the same chord, then it means that whichever angles are being suspended at the circumference ought to be equal. So this is the simplicity of circle theorem 2, and it's really so far the easiest among the theorem we've discussed in my lesson. So I'll actually be drawing curtains on our precise elaboration on circle theorem 2, and then I'll do well to continue with circle theorem 3, and we'll also have derivations on that. So prior to drawing our curtains down, I would once again remind you guys over there to subscribe to my YouTube channel, like my videos, and also do well to share these videos among your colleagues out there who might be in need of this knowledge. And for that matter, we'll actually be closing this lesson. Okay, bye bye.